Ok, habiendo agradecido al
Right.
señor.
Having thanked Mr. Kim for his presentation and of course inviting each of you to continue with your questions for our panelists, I would like to introduce our next panelist, Mr. Patrick Ferrer. Mr. Patrick Ferrer, you are already with us, aren't you? Yes, I am connected. Welcome, Patrick. Patrick is country manager from AFRI. In this case, as we've been showing different technologies related to this area, AFRI specialty is different compared to the specialty of battery storage. They are specialized in hydraulic aspects. Patrick is Master in Sciences of the Zurich Federal Technology Institute in Switzerland. He's an engineer. He worked in energy and hydroelectricity areas in 2006, such as Comenco Power Engineering, which was procured by AES Consulting and then by IPLC. In 2015, Mr. Führer opens the office for Chile of Pori, which became precisely in what is AFRI today in 2019. He participated in many hydropower and storage systems as a specialist or project manager in different stages of project design, both in terms of due diligence, technical due diligences, such as well as commercial for the implementation of these projects. He has participated in renewable transmission energy transmission projects in the design stage as well as implementation stage. He has experience in projects in Switzerland, Albania, Laos, Colombia, Argentina, Panama, Honduras, among others. For others, it's a great honor having his presence because beyond his experience, it allows us to learn from what's been this aspect in other countries. Thank you, Patrick, for joining us today and welcome. Okay, muchas gracias. Thank you, Felipe, for your kind introduction. Good afternoon, everyone. Thanks for the invitation to SEGRE and the organization committee to participate in this event. And thank you for having this room as a civil engineer and this more specialized group in the electric side. As mentioned, we in AFRE, we are not manufacturers. We are not owners of any particular technology or product. We've got a purely technical view as consultants. And today, I would like to show you. I would like to expose about storage, hydraulic storage systems, as called also in English pump storage. We've heard about them today and what kind of flexibility they may provide to the electric system, to the electric grid. This concept have already researched a long time ago. I think the pioneers or the first researchers began more than 100 years ago. And the first projects were already implemented 60 years ago. Then there's plenty of experience and there's plenty of development in terms of this technology that it just uses the gravitational energy of a water stream through a reversible turbine or a set of turbine and pump separately. This was developed in that time to storage energy surpluses generated by a thermal plant or nuclear plants, which are not easy to decrease the power of generation. Then that way, taking advantage of the difference between demand and consumption to move energy typically from the night to the day. Today, with the higher penetration of renewable energies, the focus shifts a little bit, as we've seen in many presentations today. and the generation profiles during the day along different seasons of the year have changed. We've got intermittency, in particular of wind energy, and this generates these intermittent profiles where we have to start to regulate generation or energy consumption. This also means the importance of the flexibility and how fast we can adjust consumption or generation power in very short time has increased to provide complementary services or ancillary services. Well, as we've seen in other presentations today, we've got this picture with the different technologies available. Let's figure out how well can pump storage fit here. It has a range for long-term storage capacities, typically due to higher power or longer hours, precisely to take advantage of a scale economy, but it also has certain limitations, certain constraints that in time with technological development have been improved. But at the end of the day, I think in terms of flexibility and storage for the energy matrix, it is a set of different technologies where each one has room. But as an important item is maturity. There's a lot of development. The different storage technologies or electric storage, thermal storage, and of course, hydraulic storage is the most advanced in terms of development. Sometimes it might be important when you reach the moment of funding a project or you look at the reliability of the technology, which is also important. That's why more than 90% of the installed capacity worldwide comes from this kind of technology. Then today, my purpose, my goal is to show you a little bit what's available in the market today and what kind of flexibility the different technologies may provide. The most simple we've got are reversible turbines at fixed speed. Just like any other hydraulic turbine, today they have their operation point and it could be shown with the curve on the right in the pump mode. And in one duty point, and that's it. This is the simplest equipment and of course the cheapest with a lower cost. On the other hand, it has a range, operation range in terms of generation in comparison then when flexibility started to be increasingly stronger, as well as ancillary or complementary services, in particular in interconnected grids across Europe and of equipment with variable generators, with variable speed generators and engines started developing. With that, we increased the operation range, in particular in the pump mode. As we can see in the right side, it is not a line, but it is a full plane, which give us further options for dispatch by the system, the transmission coordinator. And it also provides certain increase in terms of flexibility in the generation mode. It also has a quick ramp up abilities within a few seconds, of course, at a cost. It has a higher capex, higher capex than a simple piece of equipment. And the space, of course, this equipment are bigger. They have a set of additional electronic devices that have to be implemented within the machine building, the machine house. Lately, the latest technology aims to projects with higher jumps, with higher hydraulic pressure, and also want to increase the operation range to provide even more ancillary services and having more flexibility in the dispatch. That's basically a consequence in the electric market. There's increasingly more renewable energies in the different energy matrix and more intermittency, more intermittent energy that is introduced into the grid. That's why this is quite similar to the development of what's going on today in Chile with high penetration of renewable energies and everything which is being planned. Then these thermal units or these tertiary units, there are two pieces of equipment separate, a turbine separate from a pump. Many times, due to the pressure, they have many stages. In the picture below, we can see a three-stage pump, which allows a very quick shift in the direction of the flow. A very interesting thing in this case, it is not only applicable for tertiary units, but if we've got reversible turbines with many units, not only one unit per plant, it is the hydraulic short circuit mode. That means we can take advantage of the full operation range, 100% of consumption up to 100% of generation of the equipment. And that could mean that at the same time the turbine is generating and the pump is consuming. Then the real or total consumption of the grid is the difference between the pump and the turbine. With that, we basically increase that action range we've seen before, and it is shown here again. In red is the turbine action range, and in blue is the pump action range, and what is overlapped is the area is both pieces of equipment working at the same time. Unlike other storage systems, the hydraulic storage at the end of the day is a consumer, but the efficiency of the cycle depends upon many things. From the energy consumed, we've got electric equipment, mechanical equipment, and civil works, which depend increasingly more on what's the full project and civil works layout is like. Typically, the efficiency of the full cycle is around 70 to 80%. Sometimes are over 80%, but compared to batteries, for instance, ion lithium-ion batteries, the wearing of these systems is almost zero, and they have a much longer lifespan compared to battery. In Europe, there are projects in operations for 80 years. Of course, maintenance is in place and some changes, but it is an asset with a very long lifespan. The other topic I've shown what kind of services this could be applicable for. Here at the bottom of the slide, we can see the different technologies I have already mentioned. And this green area is where typically is the intermittency of renewable energies, the most common such as wind and PV. As mentioned earlier, the range increases as more technologies are introduced, but we are typically talking about seconds up to several hours or even several days. And here I put in terms of time between generating 100% up to pumping at full capacity. That also depends upon the requirements you put to your project. You may reach up to 90, 60 seconds or a couple of minutes, depending upon the main purpose, how flexible, how fast the ramps have to be, how quick you want to deliver energy or consume energy. But it is not as quick as other systems we've seen today, but I think it provides or it could accommodate very well to the different requirements by most of the electric grids. At the end of my presentation, I've got a couple of examples we are developing today that show what is possible and also a trend. And these are examples that could be interesting at the moment for Chile. The first project is a project aimed for the interconnected market in Europe. Here in Finland, this is the deepest mine in Europe, which is in the process of closing its activities within the next few years. And they are assessing what to do with this later on. And one of the studies we did was assessing whether we can reuse part of this infrastructure for a storage system. Here with a 1,400 meters, the nice thing is that the volumes of waters are slow because of the height. It is a ternary unit with a pump and a Pelton turbine separate from each other, and that provides the full flexibility range. This in the context that in Scandinavia, they are developing a lot of wind projects that will require that balance for those projects. With that height, this is not developed yet. It would be a world record in this moment. Typically, projects have less height difference. The second case is a project in Israel. This is something very current. is a desertic country like Chile in the north, where very similar conditions in the future. In this case, they found the problem that they cannot develop more solar energy. With that project, this is a multi-purpose project because at the same time it also stores water for crops. Here, this project is going to provide about 1.3 gigawatt hours in the future, and it will allow to install renewable energies in this region. That is basically my purpose in this presentation. The hydraulic storage has some limitations, as I mentioned at the beginning, but there is technological development, and there are also ways for us to get rid of this topographic, or you can take advantage of this topographic constraints, and you can get rid of the constraint of the scarcity of water, and we can show that there's room in the transition, the energy transition, with high penetration of renewable energies. Thank you, Patrick. Besides, you're specialized in engineering and you've got very good experience on what's somehow preparing for this kind of projects. Then thank you very much for giving us a different alternative to batteries. Chile has different geographies, and we hope technologies may live together, and innovation and development is necessary in that sense. Of course, we invite you to kindly stay with us to share after the presentation. After Alejandro's presentation, we will see a small video, and then we will open a Q&A round to share amongst all the panelists in this module today and the attendees. Thank you again.